everyone. Thanks so much for joining today. We're going to be giving a talk on Azure Linux and our learnings from building a cloud-optimized Linux distribution. Quickly to go over the agenda, we'll start with an intro to what Azure Linux is. We'll be discussing the different technical and operational challenges we've had to balance. We'll discuss how it's integrated with other cloud services like Azure Kubernetes Service. We'll discuss support and lifecycle, roadmap and integration, and then have time for Q&A. And I'm Flora. I'm a product manager on the Azure Linux team at Microsoft, and I focus on development of the Azure Linux container host that's available for Kubernetes scenarios.
And I'm Poorvi. I've been working with the Azure Linux team for the last 6-ish months. I've been focusing on driving the strategy for the next version. And then prior to this, I was working for Amazon Linux at AWS as a PM. So I have a couple of years of Linux experience at this point.
Awesome. I guess just want to start with, at a high level, what Azure Linux is. Essentially, it's a Linux distribution developed by Microsoft and tailored for Azure that we build, validate, sign, and maintain in-house. We released Azure Linux internally over 4 years ago, and now it has grown to power the majority of first-party or internal Linux cores at Azure. And so some examples of the services that are running on Azure Linux are called out in that logo wheel there. But to highlight a few, the Azure Kubernetes Service infrastructure is running on Azure Linux. So the entire underlay of this service is powered by Azure Linux today. Different security services like Defender run on Azure Linux. Xbox and Office, more well-known Microsoft products, are also running on Azure Linux. And then not called out in the slide there, but within the last year, LinkedIn actually finished their migration to Azure Linux. So their whole bare metal infrastructure is actually running on Azure Linux. So that sets a bit of context into what internally usage of Azure Linux looks like. But moving on to why we built Azure Linux, because I feel like that's a question we always get when we share that Microsoft has a Linux distribution. And so the reality is that the majority of Microsoft services and Azure services, either run on or rely on Linux. And when there was no central Linux distribution at Microsoft, this posed operational challenges where each service was running their own distribution of choice and in turn dealing with their own compliance work, CVE management, trying to optimize for performance. And essentially there became need for a central Linux distribution at Microsoft that could kind of streamline this work and secure the supply chain end to end. And so we specifically built Azure Linux to address these challenges of resiliency, security, compliance, and performance. To touch on those briefly in terms of resiliency, we needed to offer a distribution with very rigorous package testing and stable package versions to kind of minimize risks of regressions and outages. We needed a secure distribution that improved the CVE experience with strict SLAs, hardening with secure defaults, and basically securing the supply chain. To satisfy the compliance requirements of Microsoft services and many Linux users, we needed to ensure the distribution was FIPS certified and FedRAMP compliant. And then finally, we needed a team that could basically optimize the distribution for performance across a wide array of environments, spanning from the cloud down to the edge. And so, getting a little more underneath the hood here and looking at how we put the Azure Linux distribution together. So at its base layer, we take the upstream Linux kernel. The current release of Azure Linux is Azure Linux 3.0, and we're running the 6.6 LTS kernel. And then we optimize it for Azure by adding Hyper-V drivers and hardening the kernel with secure defaults. We also ensure that the kernel basically supports the various different silicon architectures used in Azure, so like x86 and ARM64. And then on top of the kernel, Azure Linux builds, it says 10,000, I think it's getting closer to 15,000 packages that are available on packages.microsoft.com. We'll link to that at the end of the deck, but that's our package repository. And I will note here that Azure Linux is an RPM-based distribution, and it's not a direct fork of any other existing Linux distribution. And yeah, we build packages from scratch to ensure a secure supply chain, and critical CVEs are made available within a defined SLA for our like commercially supported images. And for those commercially supported images, we release a new Azure Linux image on a monthly cadence. And so now addressing some of the different operational challenges that we've had to consider and balance and kind of learn to address when building the distribution. The first one there is package management. We've had to learn to find a balance between having a minimal footprint and minimal packages for security reasons and CVE reduction, while still adding packages for functionality and satisfying a wide array of use cases from different Linux users. Version control is something we've also had to find a balance between basically updating to the latest version for new features while still keeping critical components of the distribution stable for like workload compatibility. And I'll talk more about our kind of like stable yet secure approach that we've opted for shortly. The third is community engagement. I think we all agree here that effective communication and collaboration with open source contributors is essential for the success of any Linux distribution. And then finally, compliance. So obtaining FedRAMP certification for a new Azure Linux version is a timely, lengthy process. And we've had to learn how to simplify this. An example of this being the SymCrypt module, which has allowed us to use essentially any version of OpenSSL. And so that brings us to the integration of Azure Linux with other cloud services. So today, Azure Linux is externally available to Azure users via Azure Kubernetes Service. So the Azure Linux container host is essentially a tailored Azure VHD for Azure Kubernetes scenarios. And internally, the large majority of first-party Linux on AKS, or Azure Kubernetes Service, runs on Azure Linux today. So some of those services called out there being Office, PlayFab, and HD Insight. But again, getting underneath the hood here, Azure Linux essentially provides the node operating system on AKS, and it's enabled via the Azure Linux OSQ parameter. And on the screen there, you can see the versions of some of the critical components of the 3.0 Azure Linux container host. So we're using systemd 255, runc 1.2. We're now defaulting to containerd 2.0. And as I mentioned earlier, we're running the 6.6 LTS kernel. And oopsies, hit back there. For the container host image, we have made the decision to keep the footprint small by selecting basically a subset from our package repository of just about 500 packages that are necessary for running containerized workloads. And it's available for different scenarios. It's available in the cloud via Azure Kubernetes service. It's also available for edge scenarios via AKS enabled by Azure Arc. And then we also support with Azure Linux different use cases like kernel level isolation and confidential compute with our Kata and Kata CC offerings, which basically increase like security and isolation in like shared Kubernetes environments, or maybe if you're running like a multi-tenancy scenario. And I would say that one advantage of building a Linux distribution at a cloud company is that we do get to work very closely with the AKS team. So when it comes to like feature development and support requests, we get to collaborate quite closely with the AKS side of the house. And yeah, there are, many different security challenges that we have had to learn to address with the container host. And the first is CVE experience. So in an effort to reduce the number of CVEs impacting our image, we have opted to build the container host with a smaller footprint. So we remove packages that are one, maybe not necessary for running containerized workloads, or two, have an especially high CVE history. And in the next slide, I'll have some examples of those. And then when we build the distribution, we set kernel configs fairly aggressively to lock down certain features. One example of this is by default, we don't load any unsigned drivers. So any driver that gets loaded in the kernel needs to be signed with a trusted key. I would say that although this does increase our secure defaults, it has made it difficult at times for certain like third-party services to integrate with Azure Linux. So that's been something that we've had to learn to balance. Sorry about that. And then let's see, we also offer a regularly patched FIPS enabled image on our container host. And the Azure Linux container host passes all the CIS L1 benchmarks, which are composed of like over 200 unique security rules. And yeah, this basically just illustrates the point that we have. These are rough numbers, but between 200 to 250 packages fewer in our container host image. And yeah, we basically remove unnecessary packages with a CVE history. So this is things like unnecessary drivers and GUIs and text editors. And I would say that this design decision has not only helped us address our security challenges, but it's also helped us address like performance concerns and performance optimizations too, which I'll touch on more shortly. But yeah, I would say in terms of resiliency challenges, one of the most valuable attributes, I would say, of our partnership with AKS is that we get to collaborate on testing. So when testing package or image updates, the Azure Linux team actually runs the entire AKS end-to-end test suite on our existing pre-release artifacts. So we basically get to test for a wide range of end-to-end scenarios, like test for different, AKS cluster operations, and test that different AKS add-ons and extensions are validated on the Azure Linux image. And basically, if any of those fail, we wouldn't publish the image to PMC or to the AKS team. And then earlier, I discussed kind of the operational challenge we're facing of package versioning. So a decision that we've made is that for the life cycle of an Azure Linux major version, which has historically been about 3 years, we opt to not update the major versions of the critical components of the distro. So things like the kernel, run C, system D, these are going to stay on stable versions. And instead, if those communities make like critical security fixes in later versions, we would opt to backport those changes. So we've settled on this kind of stable yet secure approach to try and minimize regressions, while still, of course, like prioritizing patching for security reasons. And then, last one I will touch on is performance. We make some optimizations when building the Azure Linux binaries, and since we do have that reduced, smaller footprint, we have noticed performance improvements in terms of like AKS kind of cluster CRUD operations, like cluster create, upgrade, delete. And then I think we've learned that not only is it important to prioritize performance improvements, but also performance stability. So now we run a full set of like performance benchmarking test suites before any new Azure Linux release. So these are things like mem bandwidth, sysbench, FIO, iperf, stuff like that. But I will pass it off to Poorvi now.
So we want to talk a bit about the release cadence and the support cycle that we currently follow. We do a major release, or we aim to do a major release every 2 years at this point. And then, like Flora mentioned before, with every new release, we want to do a new version of kernel, whatever is the latest upstream available LTS kernel, and then kind of give a refresh on most language runtimes, upgrade everything to whatever is the latest upstream. And then we also release a new image every month, which is sort of like a minor version, if you want to call it, of the current major version. So everything remains stable and intact. So we try not to introduce any sort of breaking changes to the environment, but at the same time, we introduce like any bug fixes, any new packages that customers want us to add, we try and add those. And then security patches, bug fixes, and any minor updates. Now, we do release an image every month, but if you want to access any of those bug fixes immediately, you can always get it from the repository, which is packages.microsoft.com, and just upgrade directly from the repository. And with these monthly images, we also do release notes on our GitHub page every month. And I think in the last slide, we have all these resources listed out and linked, so you can access those. And then let's look at the current Azure Linux roadmap. So 2.0 was released in 2022, and it is still being maintained. It's reaching very close to its end of life date right now. And then 3.0 was released last year. Like Flora said, that was released with the 6.6 LTS kernel. The aim here is to provide that good balance between stability and innovation, and which is why we're at a 3-year life cycle right now. And technically, that's not considered LTS because it's a bit shorter. But again, like we mentioned before, we're trying to really tailor this distribution to Azure customers so that you can use like the most optimized version of a distribution on Azure Cloud. So for that, every 2 years, we aim to release a new major version. This will bring you like all the latest advancements like kernels, packages, features. And then the first 2 years of the distribution are the active development phase, like any other distribution. During this time, we look at like every feedback on our GitHub, any issue that was created, or like any package request that comes in through our customers, and we try to add that. But then the last year, we focused solely on stability and security. Stability is super important in this last year, and we try to not introduce any breaking changes. So this is the additional year of maintenance and support. We'll still keep giving you the security updates, the CV fixes, bug patches. It is going to be security first. We're not going to leave any package unpatched. But we will not introduce any sort of disruptive change. And provide you that stable environment while you migrate to the next version. Again, if you compare this to another or like any other traditional Linux distribution like Ubuntu, which follows a 10 or 11 year or a really long LTS, it is slightly or very shorter compared to that. But by releasing new versions every 2 years, we're trying to ensure that you always have access to like the latest Linux innovations, like the latest LTS kernel, latest versions of packages. And so we're trying to make it ideal for cloud native workloads. And then, okay, communication and engagement. So like Flora mentioned, this has been challenging, trying to get enough communication and engagement with the community. And we're trying to make efforts in every direction to encourage people to collaborate with us. It is one of our core values. Our GitHub repository is the central hub for it. Again, the links will be on the last slide, so you can always just reach out to us through that. And we very actively monitor the repository. It's a direct and transparent feedback loop. So whether it's a bug, you have a question, you have a feature request, you want to give us feedback on, I don't know, like maybe change our LTS or anything like that, your input will be seen through our GitHub. And we also try to keep everybody informed through our release notes on the GitHub page. And yeah, again, we want you to help us shape Azure Linux. So yeah, use that to request a package, report a bug to us, offer any sort of feedback. So next, this is something called the image customizer. This is an open source tool for modifying Azure Linux images using YAML or JSON. And it supports various image formats. It can be used via a container or an executable. And then it has integration with existing tooling. So like containerd kata, I think that's on the next slide. Perfect. So yeah, super performant. You can customize images without the overhead of having to boot a virtual machine. You can leverage root. It's versatile, supports various range of customization operations. And then it's clean. You don't need to download or install any large toolkit. And it's flexible. So it works across multiple host environment, and it supports variety of input images, variety of output formats. And then, okay, so this is our current integration with other software vendors looks like right now. You can see all the logos up there. We have initiatives that we contribute to, like systemd, RPM. We have various DevOps integrations, monitoring tooling like Prometheus. We have networking integrations, and then security like Qualys scans for our CVEs. And I think Flora did already go into the range of AKS add-ons and extensions. And again, it's a list that we're working on, and we have various other vendors in pipeline right now that we are trying to integrate with Azure Linux, and we'll keep working on growing this list as we go. And then lastly, this is the various ways in which you can communicate with us. We do have community calls. We have the link to our repository that I mentioned before. You can access our release notes there. You can, yeah, our GitHub link is right there. So please feel free to reach out to us and bring like any suggestions, any feedback, any questions. And that is all.